Welcome to 5.3, where we're going to talk about multiplying with decimals. Multiplication with decimals is pretty straightforward if we are confident in what we've learned so far about multiplication with integers and dealing with fractions. Then decimals is going to be an extension of that. So the first thing that they're going to ask us to do is to think about how decimals relate to fractions. So they're going to ask us to multiply by thinking about our decimals as fractions. So if we multiply 0.5 or 1/2 times 0.3 or 3/10, so 5/10 times 3/10, then if we want to write this as a fraction, then we can write this as 5/10 times 3/10. We can simply write the number after the decimal point over its place value, over the final place value, in this case the tenths. And then we can multiply. When we multiply fractions, we multiply straight across. So we have 15 over 100. And then, of course, if we were to leave this as a fraction, we would reduce. But if we wanted to write this as a decimal, it'll be straightforward because decimals are always in powers of 10, hundredths, thousandths, then we're always going to end up with a power of 10 as our denominator. So we're always going to be able to write this as a decimal. So this is going to be 15 over 100, so 15 hundredths. And so you can see I multiplied numbers. There were 2 decimal places in the factors total. So there are 2 decimal places in the product total. And we'll see that's a pattern that continues to repeat. So let's multiply similar numbers, but now just different place values. So let's multiply 5 hundredths times 3 thousandths. So it's going to get much smaller. So let's look at this as fractions. So 5 hundredths times 3 thousandths. Multiply straight across, so it's 15. But the question is, what's the denominator? 100 times 1,000? Well, that's 100,000. And so that's 15 100,000ths. So that's the tenths, hundredths, thousandths, 10,000ths, 100,000ths. So hopefully it makes sense how fractions and decimals are connected. Now what we can do is we can sort of free ourselves of having to use fractions. That was just as an example so that we could connect the dots. Now we are free to just multiply decimals. And so here's what we're going to do. We're going to multiply the numbers as if we're just multiplying regular whole numbers. And then what we'll do is we'll collect the number of decimal places. In this case, there's 1, 2, 3, 4, 5 digits to the right of the decimal place total in both factors. So that means our final product is going to have 5 decimal places in it as well. And so we'll see how that works out here. We're going to go ahead and multiply the numbers as if they were whole numbers. So 2 times 7 is 14. 2 times 8 is 16. So add the 1 and carry the 1. 2 times 9 is 18. Add the 1, carry another 1. 2 times 2 is 4, and 1 is 5. Add a 0 because I'm changing place value here. So 8 times 7 is 56. 8 times 8 is 64, and 5 is 69. 8 times 9 is 72, and 6 is 78. 8 times 2 is 16, and 7 is 23. All right, and now I'm over 2 places, so 4 times 7 is 28. 4 times 8 is 32, and 2 is 34. 4 times 9 is 36, and 3 is 39. 4 times 2 is 8, and 3 is 11. And now I'm over 3 decimal places, or three place values rather. 2 times 7 is 14, carry the 1. 2 times 8 is 16, and 1 is 17. 2 times 9 is 18, and 1 is 19. And 2 times 2 is 4, and 1 is 5. Okay, so now if my multiplication of my subproducts is correct, I should be able to add these up. And then once I add up all my subproducts, I can move my decimal point 1, 2, oops, let's try that again. Move it in 1, oops, let me redo this. 1, 2, 3, 4, 5 places. So 74.13734. And that's about 75. And that kind of makes sense because I'm multiplying about 3 times about 25. So it makes sense. So I probably did my math right. My subproducts are probably correct. I can check it on a calculator. The important takeaway is that when you're multiplying decimals, you basically multiply as if you had whole numbers, except you keep track of how many decimal places you had in your factors. So if you have 3 in one and 2 in another, you have a total of 5 digits to the right of the decimal point in your final product. All right, we'll try another one here. So we're going to multiply 3.05 times 4.36, and I already know there's 2 place values to the right of the decimal in each one of my factors, so I'm going to have a total of 4 in my product. So now I'm going to go ahead and multiply. 6 times 5 is 30. 6 times 3 is 18. 3 times 5 is 15. 3 times 3 is 9. 4 times 5 is 20. And 4 times 3 is 12. So if I added my subproducts, or if I did my subproducts correctly, and then I added them correctly, let's see. Then I should have 1, 2, 3, 4. 1, 2, 3, 4 digits to the right of the decimal. So 13.298. And I don't actually need this extra 0 here. I don't need that trailing 0, although it's not wrong to put it. So it's optional. All right, so now we can incorporate plus and minus signs, right? So if I'm multiplying a negative by a positive, as in the case of A, right, negative 5 times 3.4, I know a negative times a positive is a negative, so I know my product is going to be negative. And then I can actually do my multiplication here to find out. So 170 is what I get when I do my multiplication, and I have to recognize that there's 1 digit to the right of the place, to the right of the decimal point. So I need 1 digit to the right of the decimal point in my product. So that's 17.0, or maybe just 17. And B, here it's a negative times a negative. So I know my product is going to be positive. So I'm actually not even worried about writing a sign, since the positive doesn't need a sign. Now, 4/10, so part of 1 times another part of 1, 8/10, is going to be an even smaller part of 1. So it's going to be even smaller, and that's what I would expect. So when I go to do this math, 8 times 4 is 32. And then I could multiply by 0, but it's not going to do anything for me. But what I do need to recognize is that when I move my decimal point 1, 2 places over, I do need to add a leading 0. Okay, so now that we can multiply exactly, let's estimate. So in A, we've got 29.4 times 8.2. So a good estimate would be about 30 times about 8. And 8 times 3 is 24, so 30 times 8 is 240. So that would be a good estimate. All right, B, 68.5 times 172. So now, to round here, maybe we would round this to, say, 70, and round this to 170. And then we could multiply, let's see. So 170 times 70. The good news is here these zeros aren't going to really change anything. So what I can do is I can just multiply the 7 times 17, and I can add a couple zeros at the end. So 7 times 7 is 49. 7 times 1 is 7, and 4 is 11. Add a couple of zeros, and there's my estimate. All right, C. 6.32 squared. Okay. Well, let's round 6.32. Let's say that's about 6 squared, which is about 36. So there's my estimate. So when you're estimating with decimals, go ahead and round first, then do your rough calculation, and that will give you a ballpark for where your answer should be when you go to do your exact calculation. All right. So now we can combine what we're doing with an extra step here. In this case, we're going to add inside the parentheses, because we want to do what's inside parentheses first. And then we'll multiply. And to do that, I'll probably stack it over here. So I have 4 decimal places in my product. So I'm going to have 4 decimal places in my factors. So I'll have 4 decimal places in my products. So 5 times 3 is 15. 5 times 10 is, 5 times 2 is 10, and 1 is 11. 5 times 4 is 20, and 1 is 21. And then I've got to move this decimal 1, 2, 3, 4 places in. So 1, 2, 3, 4 places in, and add a leading 0. So this is 0.2115. And what they're showing you here is that you could have used the distributive property. You could have distributed this to the parts inside, right here and right here. And then you could have added those subproducts. And you'd still get the final answer. All right, let's do another one. We're going to simplify this one. So we've got to do anything inside parentheses. There's nothing to do inside parentheses, so we're on to exponents. So we're going to have to square this 3.2 first. So 3.2 times 3.2 So that's 4.8 plus 12 times 3.2 squared was 10.24. I just figured out there. Now I'll do the multiplication first. So I'll do 12 times 10.24. So it's going to be about 12 times 10, so about 120. And then I've got to move the decimal place 2 in. So 1, 2. So yeah, 122.88 is what I got. So about 120. So that was close to my estimate. And now I can go ahead and add. And I'll just move this one over here so that I can add straight down. Oops. 7, 2, 1. So 127 and 68/100ths. So hopefully you can see what we did. We went kind of quickly, but the basic idea is that we're following the order of operations, and we're doing it one piece at a time, and we're incorporating what we know about decimals now, adding, subtracting, and multiplying. All right, so Sally earns $6.32 for each of the first 36 hours she works in 1 week, and $9.48 in overtime pay for each additional hour she works in the same week. How much money will she make if she works 42 hours in 1 week? So we've got to figure out first what she's working in overtime and regular pay. So if she works 42 hours, and that's 36 hours of regular pay and 6 hours of overtime. Now, how much does she get? She gets $6.32 for her regular pay. And then she gets $9.48, time and a half, presumably here, for the 6 hours of overtime. And hopefully you can see this is why the order of operations is important, because we have to multiply here to find out these subproducts before we can add to find her total paycheck. So when we do this math, we find out that 6.32 times 36 is 227.52. So $227.52 in this case. And the overtime, $9.48 times 6 hours, is $56.88. And when we add that together, we get $284.40 for her 42 hours. For 42 hours. So let's review some of the key concepts here. If you multiply 34.76 times 0.072, how many digits will be to the right of the decimal point in your answer? Well, we can count up how many are in the factors. 1, 2, 3, 4, 5 total. So there should be 5 decimal points to 5 digits to the right of the decimal point. All right, B. To simplify the expression right here, what would be the first step according to the rule for order of operations? We would have to do this multiplication first, right? So you'd have to multiply first. C. What is the purpose of estimating? Estimating is useful so that you can get a ballpark and spot errors. Because if you get an answer that's way different than your estimate, then chances are that you made a mistake somewhere. D. What are some applications of decimals that we use in our everyday lives? Well, there's all sorts. When we're weighing things, we use parts, we use decimals. Another great example, though, I think that everybody's familiar with is money. And that's probably the biggest example that we have in our lives. And, of course, we use decimals in anything scientific. So those are just some of the ways we use decimals, and hopefully you've got some real-life experience to draw on in this chapter, and we'll see you in 5.4.